Please settle a problem. Given that, given that air consists of 21 percentage oxygen, 21 percentage oxygen, and 79 percentage nitrogen by volume. Which means that this is a volumetric analysis of air. Okay, volumetric analysis of air gives that it contains 21 percentage of oxygen and 79 percentage of nitrogen in it. Okay, so determine first one, the moles of nitrogen per moles of oxygen. Moles of nitrogen per moles of oxygen. It means that how many moles of nitrogen is there per 1 mole of oxygen. Okay, if 1 mole of oxygen is there, how many moles of nitrogen is the particular air? Second question, the partial pressure of nitrogen and oxygen. Partial pressure of nitrogen and oxygen. If the total pressure is atmosphere, the total pressure is atmosphere. It means the total pressure is atmosphere pressure. One bar. Atmosphere. The third question is kilogram of nitrogen per kilogram of mixture. Kilogram of nitrogen per kilogram of mixture. It means that how many kilogram of nitrogen by mass, by how many kilogram of nitrogen is there per 1 kilogram of mixture. If we are taking 1 kilogram of that air mixture, how many kilogram of nitrogen will occur in it? First question is to find out the number of moles per number of moles of nitrogen present in 1 mole of, if 1 mole of oxygen is there, how many moles of nitrogen is there? So we must find out partial pressure of nitrogen and oxygen. If total pressure is atmosphere pressure 1 bar. Then third question is to find out the kilogram of nitrogen per kilogram of mixture. So given data are the volumetric analysis of air, that it consists of 21 percentage of oxygen and 79 percentage of nitrogen. Okay, so given data, answer given data. I don't. We know total volume is V, right? Total volume is V. That denoted by V. So what is the volume of nitrogen in it? The total volume of mixture, we can take it as a V. So how many? So what is the volume of nitrogen and oxygen in it? Okay, 21% oxygen is like 21% oxygen. Therefore, 0.21 V. 0.21 of V. V is the total volume, and 21% of that V is oxygen. Therefore, 0.21 V is the volume of oxygen in it, equal to VO2, 0.21 V. Nitrogen, 79%, right? Therefore, 0.79 of V. Total volume is V, and 79% of that V is nitrogen. Therefore, 0.79 V is VN2. VN2 and VO2. Okay. Then, what is the number of moles of oxygen in the mixture? We are taking first question. First question is to find out moles of nitrogen per 1 mole of oxygen. So we can consider the number of moles of oxygen as 1. Right. You want to find out the number of moles of nitrogen per mole of oxygen. That is per 1 mole of oxygen. So we can take, for the first question, we can take number of oxygen, number of moles of oxygen as 1. Number of moles of oxygen as 1. That is NO2. Small n is a number of moles depending on the small n. NO2 equal to 1. 1 mole. Number of moles of oxygen is 1. So we want to find out if the volume of nitrogen in the mixture is 0.21 V and that of nitrogen is 0.79 V and number of moles of oxygen is 1 mole, then how is the number of moles of nitrogen? NN2 want to be find out. NN2 what do we find out for the first question? NN2. So how we can find out? Our equation, the only equation we have is PV equal to nRT. PV equal to nRT. So here the question is number of moles depending on the question, and we can take the PV equal to nRT as PV equal to nR0T or R bar T, that is universal gas constant. PV equal to nRT. PV equal to nRT. We can take N0, R0 or R bar or G, anything. Is universal gas constant 8.314. Okay. So this is the only equation we have. Write down the two equations related to oxygen and nitrogen. Oxygen only, nitrogen only, that equation. That is, pressure is same. This total pressure P. Therefore, PV of O2 equal to NO2 R0 into T. T is unknown value. Also write down the equation for nitrogen. PV of N2 equal to N of N2 into R0 into T. Equation 1, equation 2. We have written the two equations for oxygen and nitrogen, PV equal to nRT. We have written two equations. First one is for oxygen and second one is for nitrogen. Then divide 1 by 2. 1 divided by 2. 1 divided by 2 equation. Therefore, P and P get cancelled, right? R0 into T, R0 into T get cancelled. Remaining term is, we are divided the particular equation. That is, therefore, the remaining term is VO2 by VN2 equal to NO2 by NN2, right? VO2 by VN2 equal to NO2 by NN2. So here we want to find out the value of NN2, right? NN2. We know that NO2 is 1. VO2 0.21 B, VN2 0.79 B, right? So substitute the value and find out the value for NN2. NN2 equal to VO2 by VN2. Right. Okay. NO2 divided by NN2 അങ്ങോട്ട് പോകും, ദടിയിലേക്ക് വരും. That is VO2 divided by VN2. Right. So NO2 is 1. NO2 is 1. We have taken NO2 as 1 mole. VO2 is 0.21 B. 0.21 B divided by 0.79 B. Right? 0.79 B. Then B and B get cancelled. Therefore, the equation is 1 divided by 0.21 divided by 0.79. This is the value for NN2, number of moles of nitrogen per 1 mole of oxygen. We have taken the number of moles of oxygen as 1, and we have calculated the number of moles of nitrogen when number of moles of oxygen is equal to 1. Okay. Therefore, per number of moles of nitrogen per moles of oxygen, that is 1 divided by 0.21 divided by 0.7, or we can say 1 into 0.79 divided by 0.21, and 0.7 we will get 1 into 0.79 divided by 0.21 will be the number of moles of nitrogen, that is 3.76 moles, right? 3.76 moles. The second question is to find out the partial pressures of oxygen and nitrogen. The first question, we got the value for first question. And second question is to find out the partial pressure of oxygen and nitrogen, right? That is PO2 and PN2. If total pressure equal to atmosphere, that is 1 bar or 1 in 10 to 5 Pascal. Atmosphere means 1.023, right? So we are taking 1, P is equal to 1 bar. If total pressure equal to 1 bar, what is the pressures of PO2 and PN2? One atmospheric pressure. Okay. So write down the equation for partial pressure. Sorry, not partial pressure. Mole fraction. X. What is the equation for X? Ni by N, right? N is the mole fraction. Mole fraction, that is, mole fraction is defined as the number of moles of any one constant divided by total number of moles. Mole fraction. Mass fraction is defined as number of mass of any one constant divided by total number of mass. Total number of mass is total mass. So here mole fraction is denoted by X, and it is defined as number of moles of any one constant divided by total number of moles. Total number of moles is divided by N, and a constant number of moles can be divided by Ni. If we are taking of number of moles of oxygen, we can write NO2 by N. If we are taking of nitrogen, we can write NN2 by N. Okay, Ni by N. This Ni by N can be written as Ni by N equal to Vi by V equal to Pi by P. Relation that is Ni by N equal to Vi by V equal to Pi by P. Our condition for the last module. So here Ni by N can be written in the form of oxygen. We can take the case of oxygen. That is XO2 equal to NO2 by N. NO2 by N. We can relate that equation like this. The pressure you want to find out the pressure. So we can relate this equation into pressure. We can write PO2 by P. Also it is VO2 by V. So this equation we don't need. This equation we need, that is NO2 by N equal to PO2 by P. PO2 by P. We know that P is 1 bar. P is 1 bar. Number of moles of, that is total number of moles, we can got that number of moles of oxygen is 1, and number of moles of nitrogen is 3.76. We already got it. So NO2 also a known value, N is a known value, P is a known value. So only unknown value is PO2. So we can directly find out the value of PO2. PO2, that is your PO2 equal to NO2 by N into P. PO2 equal to NO2 by N. This equation. What is the equation? X equal to Ni by N. That is mole fraction equation. Equation for mole fraction, that is Ni by N. Okay. This NO2 by N into P. NO2. What is NO2? We had assumed that NO2 is 1. 1 divided by total number of mass is total number of moles 3.76 plus 1. 3.6 is number of moles of nitrogen, and 1 is the number of moles of oxygen, nitrogen and oxygen, into P. P is 1 bar. Total number of pressure. Total pressure is given as 1 bar. Okay. So the value for PO2 is 180. 180. We are taking 180 atmosphere pressure. So we will get the PO2 as ATM pressure, atmosphere pressure. Okay. Therefore, PO2 is 1 by 1 plus 3.76 plus 1 into 1 equal to 0.21 atmosphere pressure. 0.21. That is, if total pressure is 1 bar, pressure of oxygen in that total pressure is 0.21 bar or 0.1 atm. We are taking what atmosphere pressure as total pressure, and from that 1 atmosphere pressure, 0.21 atmosphere pressure is oxygen. So what is the number of? So what is the value of Pn2? What is the value of Pn2? How can you find out? How can we find the value of Pn2 if we know the value of PO2? Anyone? Please respond.
Sorry, equation വെച്ചിട്ടല്ലേ N 0 RT
എങ്ങനെ?
N R0 T equation വെച്ചിട്ട്
ഈ ഇക്വേഷൻ വെച്ചിട്ട് നമുക്ക് കണ്ടുപിടിക്കാം അല്ലേ? If we are taking NO2 by N equal to PO2 by P. The same method we can take NN2 by N equal to PN2 by P. Same equation we can use to find out the PO2 or PN2. ഇവിടെ NO2 പകരം കൊടുത്ത NN2 ആണ് കൊടുക്കണമെങ്കിൽ NN2 by N equal to PN2 by P. Okay, we can find the value by the same method, but there is another alternative method or a very simple method to find out PO2. As I said, the total pressure is 1 atmosphere. Total pressure is 1 atmosphere. According to Dalton's law of partial pressure, we know that E equal to P1 plus P2. Total pressure is P1 plus P2. So here only two constants are there. Nitrogen and oxygen is only there. So total pressure is 1 atmosphere pressure. That of PO2 is 0.21 atm. So what is the pressure of PN2? 1 minus 0.21. Right? P of N2 equal to 1 minus 0.21. That is 0.79. Or by using the same method that when you use to find out the PO2, you will get the same answer. 3.76 by 3.6 plus 1 into 1. We will get the same answer as 0.79. Or we can use a similar method, P equal to P1 plus P2, as that is how partial pressure says. Total pressure of the mixture is the summation of the pressure of individual constants present in it. That is P1 plus P2. Here it is oxygen and nitrogen. P equal to PO2 plus PN2. P and PO2 is a known value. Therefore, PN2 can be found out by using 1 minus 0.21. Okay. So last question. Kilogram of nitrogen per kilogram of mixture. Kilogram of nitrogen per kilogram of mixture. Okay, find out. Kilogram of nitrogen per kilogram of mixture means only mole fraction. Mole fraction, that is M of N2, mass of N2 divided by total mass. Kilogram of nitrogen per kilogram of mixture. He said that if 1 kilogram of mixture we are taking 1 kilogram, so, sorry, when we are taking 1 kilogram of mixture, how many kilogram of nitrogen present in it? That is Mn2 divided by Mn2 plus MO2 or total mass M. Mn2 divided by Mn2 plus MO2. There is an equation. It's not an equation. നമുക്ക് വാല്യൂ അറിയുന്നത് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാം. Mn2 plus MO2 total mass അറിയില്ല. So we can use number of moles of nitrogen. What is the equation for M? We know that number of moles is equal to given mass by molecular mass. N equal to M by M. Number of moles N equal to given mass by molecular weight or molecular mass. This equation N equal to M by M. Small m divided by capital, that is given mass by molecular. Therefore, what is M here? N into M. Okay. From here, M equal to N into M. Adopt that method here. What is M of N2 means? N into M. Right? N of N2 into M of N2. Then M of N2. All divided by M of N2 means same equation. N of N2 into M of N2 plus MO2 N of O2 into M of O2. The whole value is known. What is N of N2? Number of moles of nitrogen 3.76. We already know the value and 3.76. What is M of N2? Molecular weight of nitrogen. This atomic weight of nitrogen is 14. Therefore, N2 equal to 28. Number of moles of molecular weight of nitrogen is 28. 20. So M of N2 is 28. N of N2 is 3.76. The same value is here. Therefore, in the case of N2, NO2 is 1. M of O2 is 32. Molecular weight of. Any doubt? Any doubt in this equation?
No, sir.
Substitute the value. And find out how many kilogram of nitrogen is there per kilogram of mixture. Is 3.76 into 28 divided by 3.76 into 28 plus 1 into 32. We'll get the value as 0.77 kilogram. 0.7 kilogram of N2 per kilogram of mixture. 0.77 kilogram of N2 per kilogram of mixture. That is our question. Is it clear?
Yes, sir.
It's a very simple problem in our fifth module. The only equation we are using here it is PV equal to nRT and the relation between R and R equal to R bar by N, or R bar equal to R by N, that equation, that is molecular weight, characteristic gas constant, and molecular universal gas constant relation between the three, and our relation, that is Ni by N equal to Pi by P equal to Vi by V. And also we are using our mole fraction and mass fraction, Mi by M or Ni by N. Okay, these three equation or three relation want to only study in this particular fourth and fifth module. So we can write one more question and we can stop by writing the particular question and we can solve the equation in next session. So please write down the pressure and temperature of mixture and temperature of 4 kilogram of O2 and 6 kilogram of N2 oxygen and nitrogen are pressure and temperature is given, that is 4 bar and 27 degrees Celsius respectively. Determine for mixture. So here gravimetric analysis given here, like not volumetric, it is a gravimetric. It means that the constant pressure, so constant mass is given here. Is 4 kilogram of oxygen and 6 kilogram of nitrogen is there in a mixture. And its temperature is given as 27 degrees Celsius and pressure is given as 4 bar. So determine the values of first one, mole fraction of each component. Mole fraction of each component. Second question, average molecular weight. Average molecular weight. Third question, specific gas constant or characteristic gas constant, not R value. Fourth one, volume and density. Fifth one, that is last one, partial pressures and partial volume. Partial pressures and partial volume. So question is given as gravimetric analysis of a particular mixture is given as 4 kilogram of oxygen and 6 kilogram of nitrogen. Temperature is given as 27 and pressure is given as 4 bar. You want to find out the value for mole fraction of each component. This mole fraction of oxygen and mole fraction of nitrogen. Average molecular weight of mixture. Specific gas constant R value of the mixture. Volume and density of the mixture. Partial pressures and partial volume of the mixture. So here we are doing gravimetric analysis, volumetric analysis, and we are using our equations PV equal to nRT, N equal to MBM. More and more equations we are using here. The question will be asked will be 10 mark or something. Okay. So we can stop our session now, or we can continue next class.